Good day everyone. We are the students from BSEE 3A and we are going to discuss about hydrogen. Hydrogen is a versatile element that has gained significant attention in recent years as a clean and sustainable energy carrier, particularly in the context of electricity generation. As the world seeks to transition away from fossil fuels and reduce greenhouse gas emissions, hydrogen has emerged as a promising solution due to its potential to serve as a clean fuel for power generation. One of the key methods of utilizing hydrogen for electricity generation is through fuel cells. Fuel cells are electrochemical devices that convert the chemical energy of hydrogen directly into electrical energy, with water and heat as the only byproducts. The process involves the electrochemical reaction of hydrogen with oxygen, typically from the air, to produce electricity. The main advantages of using hydrogen in electricity generation are its high energy density and the fact that its combustion or electrochemical conversion does not produce harmful emissions. Hydrogen fuel cells can be employed in various applications, from small-scale portable devices to large-scale power plants. There are different methods of producing hydrogen, with the most common being electrolysis and steam methane reforming. In electrolysis, water is split into hydrogen and oxygen using an electric current, often sourced from renewable energy. Steam methane reforming involves extracting hydrogen from natural gas, but this process emits carbon dioxide unless carbon capture and storage technologies are employed. While hydrogen holds great promise as a clean energy carrier, challenges such as production at cost, infrastructure development, and storage technologies need to be addressed to make it a mainstream option for electricity generation. Nevertheless, ongoing research and investments in hydrogen technology are contributing to its potential role in a more sustainable and greener energy future. Let us now move on to hydrogen power plant. A hydrogen power plant is a concept designed for a new widespread source of electricity. Essentially, it is a facility which uses hydrogen to produce electrical energy. Working principle: large tanks of liquid hydrogen will feed into thousands of hydrogen fuel cells. These fuel cells are solid structures containing an electrolyte fluid and two terminals, much like batteries. The reactants flow into the cells, in this case, hydrogen and oxygen. They intermingle with the electrolyte to produce an electrical charge and water as a byproduct. The water flows out another port while the electricity is siphoned off the terminals and held in gigantic multi-ton batteries. The electricity resides in the batteries until it is needed, in which case it is sent out through the local power grid just like any other type of power plant. So, a hydrogen power plant is a facility that generates electricity using hydrogen as a primary fuel cell source. These power plants typically employ hydrogen fuel cells, a technology that directly converts the chemical energy of hydrogen into electrical energy through an electrochemical process. The primary components of a hydrogen power plant include hydrogen storage, fuel cells, and associated balance of plant systems. Next is the battery parts and functions. First is the electrolyte. Electrolyte is a chemical compound that conducts electricity by changing into ions when melted or dissolved into a solution. It can be a liquid or paste-like substance. Examples are ammonium chloride, zinc chloride, potassium hydroxide, lithium tin phosphorus sulfide, and sulfuric acid. So an electrolyte is a substance that conducts electricity when dissolved in a solvent, typically in form of ions. Electrolytes are vital in various electrochemical processes, including batteries, fuel cells, and electrolysis. These substances can be in the form of liquids, gels, or solid compounds with high ionic conductivity. In the context of fuel cells, which was mentioned in the previous response regarding hydrogen power plants, an electrolyte plays a critical role. A fuel cell consists of an anode and a cathode, separated by an electrolyte. The electrolyte allows ions to move between the anode and cathode, facilitating the electrochemical reactions that produce electricity. Second is the anode. Anode is the negative or reducing electrode that releases electrons to the external circuit and oxidizes during the electrochemical reaction. Those are zinc, metallic lithium, and lead. So an anode is a crucial component in electrochemical cells, including batteries and fuel cells. It is one of the two electrodes that facilitates the flow of electrical current through the cell. The anode is where oxidation reactions occur during the electrochemical process. In simple terms, during the operation of an electrochemical cell, electrons are released from the anode, and the positive ions move towards the cathode. This flow of electrons creates an electric current that can be utilized to perform work, such as powering electronic devices or generating electricity. Again, the anode is the electrode where oxidation reactions take place in an electrochemical cell, leading to the release of electrons and the generation of electrical current. Third is the cathode. Cathode is the positive or oxidizing electrode that acquires electrons from the external circuit and is reduced during the electrochemical reaction. Manganese dioxide, carbon, lead dioxide, and copper. So the cathode is another important component in electrochemical cells, including batteries and fuel cells. It is one of the two electrodes in the cell. The other being is the anode, what I mentioned earlier. The cathode facilitates the reduction reactions during the electrochemical process. In simple terms, during the operation of an electrochemical cell, electrons flow from the anode to the cathode, and positive ions move towards the cathode. This movement of electrons creates an electric current that can be harnessed to perform work, such as powering electronic devices or generating electricity. So again, the cathode is the electrode where reactions take place in an electrochemical cell. It is the site where electrons and positive ions from the anode combine to complete the electrochemical circuit, leading to the generation of electrical current.
So, ngayon naman, i-discuss na natin yung schematic diagram ng battery. So, kung makita natin dyan sa figure, meron tayo dyang electrolyte, which is mainly made of ammonium chloride, zinc chloride, potassium hydroxide, and sulfuric acid. And next, meron din tayo dyang the anode, which is the battery's negative side kung tawagin. And is mainly made of lead, metallic lithium, and zinc. And next, meron din tayo dyang yung cathode, which is the positive side of the battery, and is mainly made of manganese dioxide, carbon, lead dioxide, and copper. And meron tayo dyan yung nasa gitna, siya yung tinatawag nating semi-permeable barrier, kung saan ito yung nag-act as a barrier between the anode and the cathode para hindi lumagpas yung excess na electron, para hindi pumunta yung mga excess electron directly sa may cathode. And lastly, we have here the load to exert the energy with. So ngayon naman, i-discuss na natin yung battery construction. So sa may battery construction, kung makita natin dyan, meron tayong 5 elements. So yung pinakauna is yung battery caps. So the battery caps allows the gas to escape and prevent the electrolyte from splashing outside the battery. They also serve as spark arresters, or to keep sparks from igniting the gas inside the battery. Next naman is yung carbon rod. The carbon rod attracts the ammonium chloride and then form a positive charge. Next is the zinc case. The zinc case attracts the chloride, and due to this, the ammonium ions or the ammonium chlorides repels at carbon rod. And the fourth one is the manganese dioxide. One of the primary uses of manganese dioxide is as an oxidizing agent. It can effectively oxidize various chemicals and compounds, which makes it an essential component in the production of batteries. And lastly is the base of the ammonium chloride. The base of the ammonium chloride allows the flow of the current. So ngayon naman, i-discuss natin kung paano nag-work yung battery. So yung battery is nag-work siya kapag yung both anode and cathode is nakasubmerge sa may electrolyte solution, and nagpo-form kasi doon ng chemical reaction. So pag-usapan natin po na yung sa may anode side. So on the side of the anode, the electrolyte and the anode forms a chemical reaction in such a way that it produces an excess of electrons, making this side as negative. And as we all know, if there are too many excess of electrons, it will keep on moving or transferring from one atom to another at randomly. At the same time, it will repel one another. So the resulting scenario is that those excess of electrons will try to look for a place where there are fewer electrons. So yung place na yon sa may battery is walang iba kundi yung cathode. So ngayon naman pag-usapan natin yung cathode kapag nakasubmerge na siya sa electrolyte solution. So on the side of the cathode, the electrolyte solution and the cathode forms also a chemical reaction, but not to produce an excess of electrons, but to produce a substance that readily accepts electrons, making this side of cathode as positive. Ngayon ulitin natin. Kapag yung anode side is submerge sa may electrolyte solution, nagpo-produce to ng sobrang daming electron. And kapag yung sa may cathode side naman is nakasubmerge sa may electrolyte solution, nagpo-produce to ng substance na nag-accept ng electrons, or pwede nating sabihin na electron acceptor. So therefore, if we are going to interconnect these two along with the respective loads, the excess electron on the side of the anode will travel towards the cathode, and that particular cycle repeats on and on until the battery depletes.
Chemical reaction in zinc carbon battery. Anode, zinc. Cathode, manganese dioxide. Carbon is added to increase conductivity. Electrolyte, ammonium chloride. Overall reaction in the cell. Zinc reacts with two molecules of manganese dioxide to form zinc oxide and manganese trioxide. Note: the exact mechanism for this complicated, and there is still controversy over exact mechanism. However, the approximate half-cell reacts are: anode, zinc undergoes oxidation transforming into zinc ion and releasing 2 electrons. Cathode, 2 ammonium ions and 2 manganese dioxide molecule gain 2 electrons to form manganese trioxide, water, and ammonia. Another chemical reaction is the ammonium ion produces 2 gaseous products. 2 ammonium ion gains 2 electrons, resulting in the formation of 2 ammonia molecules and 1 hydrogen molecule. This product must be absorbed in order to prevent build-up of pressure in the vessel. This occurs by 2 mechanisms. Zinc chloride reacts with 2 ammonia molecules to form zinc amine chloride, and 2 manganese dioxide molecule reacts with hydrogen gas to produce manganese trioxide and water. This oxidation reaction releases electron, and this electron flow through external circuit, creating an electric current. Meanwhile, manganese dioxide in the cathode captures electron and reacts with proton from the electrolyte, completing the circuit. The overall process in the production of water and other compound, providing the electrical energy needed for the battery to function. Fuel cell stack. It functions through a series of electrochemical reactions in multiple individual fuel cells connected in series. Each fuel cell within a stack consists of an anode, a cathode, and an electrolyte. Hydrogen gas is supplied to the anode, where it undergoes oxidation, releasing electrons. These electrons flow through an external circuit, generating electrical power. Simultaneously, oxygen from the air enters the cathode, combining with electron and proton from the electrolyte to produce water as a byproduct. The movement of electron through an external circuit creates an electric current. The stacking of individual cells in series enhances the overall voltage output, providing a continuous and efficient sources of electricity. The chemical reactions involved in the cell collectively form the fuel cell stack, which is a key component in generating clean and sustainable electrical power. How a fuel cell vehicle works. Hydrogen stored in a tank is delivered to the fuel cell stack. In a stack, each individual fuel cell facilitates the electrochemical reaction of hydrogen and oxygen, producing electricity. The hydrogen undergoes oxidation at the anode, releasing electron, while oxygen from the air is reduced at the cathode, combining the electron and proton to form water as a only emission. This electrochemical process generates electrical power, which is then utilized to drive an electric motor, propelling the vehicle. Unlike traditional internal combustion engines, fuel cell vehicles produce zero emission at the point of use. As the only byproduct is water vapor, this makes them environmentally friendly alternatively, contributing to the cleaner transportation solution. Fuel cells work like batteries, but they do not run or need recharging. They produce electricity and heat as long as the fuel is supplied. A fuel consists of two electrodes, a negative electrode or anode, and a positive electrode or cathode, sandwiched around an electrolyte. A fuel such as hydrogen is fed up to the anode, and the air is fed to the cathode. In a hydrogen fuel cell, a catalyst at the anode separates hydrogen molecule into proton and electron, which take different paths to the cathode. The electron through the external circuit create a flow of electricity. The proton migrate through the electrolyte to the cathode, where they unite with oxygen and electrons to produce water and heat.
Hydrogen fuel cell working principle. Fuel cells work like batteries, but they do not run down or need recharging. They produce electricity and heat as long as fuel is supplied. A fuel cell consists of two electrodes, a negative electrode or anode, and the positive electrode or cathode, sandwiched around an electrolyte. Kung i-visualize natin siya, yung anode sa cathode, siya yung tinapay, tapos yung electrolyte naman is siya yung palaman kasi pinagitnaan siya ng anode sa cathode. A fuel such as hydrogen is fed to the anode and air is fed to the cathode. In a hydrogen fuel cell, a catalyst of the anode separates hydrogen molecules into protons and electrons, which take different paths to the cathode. The electrons go through an external circuit, creating a flow of electricity. The protons migrate through the electrolyte to the cathode, where they unite with oxygen and the electrons to produce water and heat. Working principle summary of hydrogen fuel cell. Hydrogen atoms enter at the anode, while oxygen is fed to the cathode. Yung hydrogen is nagsusupply nga siya dun sa anode side ng fuel cell. Tapos yung oxygen naman is dun sa cathode side ng fuel cell. The hydrogen atoms are separated into protons and electrons at the anode with the use of platinum catalyst. The now positively charged protons passes through polymer electrolyte membrane, also called a proton exchange membrane, heading to the cathode. The polymer electrolyte membrane, or PEM, is a specially treated material that looks something like ordinary kitchen plastic wrap. It only allows positively charged ions to pass into, while it blocks the electrons. The freed electron travel through a wire, creating the electric current. After passing through the circuit and the membrane accordingly, once again with the aid of platinum as catalyst, the electrons and protons meet of the cathode, where they combine with oxygen to produce heat and water as byproducts. Dito sa schematic diagram ng hydrogen power plant, may makikita kayo dyan na dalawang bilog. Yung dalawang bilog na yan is tangke. Yung isa is hydrogen pipeline, tapos yung isa naman is oxygen pipeline. Yung hydrogen, nagsusupply siya dun sa anode side ng fuel cell. And yung ano naman, oxygen, nagsusupply siya sa cathode side ng fuel cell. Para magkaroon ng great quality output, kailangan ng isang typical na hydrogen power plant, kailangan niya ng 1,000 of fuel cell. Yung fuel cell, yun yung nasa gitna dyan sa image. At yung fuel cell, nagwo-work siya na parang battery. So yung output niya is DC o direct current. Kaya makikita nyo rin dyan na merong inverter. Kaya kailangan ng inverter dyan is para i-convert niya yung DC to AC. Direct current to AC o alternating current. Direct to alternating current. At saka para maiwasan yung paglulos dahil sa mahabang transition line, ikinokonekta sa step up transformer saka sa substation para makapag-supply papunta dun sa grid. Saka makikita nyo rin dyan, merong management unit. Yun yung nagpapagana sa mga fuel cell saka sa hydrogen pipeline. Basta yun yung parang nagpapagana sa kanila. At ganun yung actual na operation ng isang hydrogen power plant. Ma-explore it. Ano nga ba yung maganda sa hydrogen power plant para alamin pa natin yung ibang katangian niya? Fuel cells have several benefits over conventional combustion-based technologies currently used in many power plants and passenger vehicles. Hydrogen is a very efficient fuel source, capable of producing more energy per pound of fuel than gasoline. This means that an equal-sized tank of hydrogen fuel would give a vehicle a greater range or more power than when filled with gasoline in an internal combustion engine. So yung meron kasing sa panahon ngayon, meron tinatawag na hydrogen powered car. Yung kotse na yun is ginagamitan siya ng hydrogen. Kung ikukumpara natin siya sa di-gasolina, kapag nilagyan natin yung dalawang kotse na ng same volume ng hydrogen sa gasolina, mas malayo yung mararating ng kotse na nilagyan ng hydrogen kaysa dun sa di-gasolina. Kasi nga, mas tipid, kumbaga ganun. Mas tipid yung hydrogen powered car kaysa sa di-gasolina. Fuel cells have much lower emissions than combustion engines. Hydrogen fuel cells emit only water, so there are no carbon dioxide emissions and no air pollutants that create smog and cause health problems at the point of operation. Dito, yung Kasi nga, di ba yung hydrogen fuel cells is yung byproduct niya ay malinis na tubig. Hindi naman yung magkakos ng pollution. Kaya yung hydrogen powered car na kotse, kung saan man siya tumatakbo, hindi yung magkakos ng pollution sa area kung saan tumatakbo yung kotse. Kumpara dun sa di gasolina na sasakyan na inilalabas sa usok, yung usok nagkakos yun ng pollution. Also, fuel cells are quiet during operation as they have fewer moving parts. Siguro kapag yung isang sasakyan, nilagyan ng yung isang sasakyan is hydrogen yung ginagamit, hindi masyadong nagbabibrate yung makina niya kumpara dun sa di gasolina na siguro malakas yung pag-vibrate ng makina niya. Kaya kung susuriin natin sa binasa ko, mainam talaga na may hydrogen power plant kasi nga less pollution siya.
So now we will talk about why does hydrogen power plants hasn't gone mainstream. So bakit nga ba hindi pa talamak yung paggamit ng hydrogen power plants? So first, hydrogen power production through methane. So about 95% of the hydrogen used today is produced by a process called steam reforming. Ang steam reforming nga is the method or the process separating the hydrogen from methane. And sabi dito, this process is expensive and it releases greenhouse gases which contributes to global warming, thereby canceling out any benefits to the environment. So unfortunately, this method nga is both expensive and environmentally detrimental kasi it releases greenhouse gases na nagka-counteract sa environmental benefits ng hydrogen as a clean energy source. So, to realize the full potential nga ng hydrogen as an eco-friendly energy source, kailangan pa natin or ng mga scientists na mag-research at mag-develop ng alternative, cost-effective production techniques. And next natin is yung hydrogen production through water. The other production method is electrolysis, which separates hydrogen from water. The downside is that it is expensive. So, the expense associated with electrolysis poses a significant barrier to the widespread acceptance of hydrogen as an energy source. So, to unlock nga ulit yung full potential ng hydrogen at para maging viable ito at accessible solution, kailangan ng mga scientists na makapag-develop ng cost-effective methods for producing hydrogen through electrolysis. So, we have to overcome this challenge para ma-ensure natin na yung hydrogen's role in a sustainable and widespread energy transition. Next is yung cost. The cost of fuel cells can be high given the use of platinum as one of the largest component materials. However, there is work underway to find non-platinum catalyst approaches. So, the affordability of hydrogen power faces a notable challenge due to the high cost associated nga dun sa fuel cells. So, it is primarily driven by the use of platinum as a significant component material. Pero, meron namang ongoing research na nag-i-aim para makapag-explore ng alternative at non-platinum catalyst approaches. So, this work holds promise for reducing the cost barrier and making fuel cells more economically viable. So, as advancement in catalyst technologies progress, the potential for lowering production costs may or could play a pivotal role in facilitating the broader integration of hydrogen power into mainstream energy solutions. Next natin is yung hydrogen storage. Scientists are still struggling with the challenge of how to store hydrogen. So, Due to its low energy density, hydrogen requires storage under strong compression. So it demands robust tanks and heavy-duty fueling lines. Yung absence or the absence of a mainstream system for hydrogen storage and distribution, nagrepresent ito ng major practical disadvantage na naghihinder or nag-i-stop sa convenience and accessibility of hydrogen as a viable fuel source. So, we need to address this challenge para maka-establish tayo ng more efficient and practical infrastructure para unlock natin yung full potential ng hydrogen as a clean energy solution.
Hydrogen leak. Hydrogen leakage can occur during many steps of its production and use. Science magazine reported in June 2003 that hydrogen leakage from widespread use of hydrogen fuel would gobble up ozone faster than CFCs do. Ang tinutukoy naman dito, which is yung maraming proseso na paggawa or paggamit ng isang hydrogen sa science man noong June 2003 para sa hydrogen leakage na makalat sa buong hydrogen fuel at gumagambala sa gobble up ozone faster than CFS do. Long Ridge Energy Generation Project. Touted as a first of its kind power plant in the United States, the Long Ridge Energy Generation Project, a 485 megawatts facility being equipped to run on a mix of natural gas and carbon-free hydrogen, is nearing completion at the site of the former aluminum smelted on the banks of the Ohio River. Pinapakita dito, ito daw ang kauna-unang power plant sa United States na merong 485 MW or megawatts na nagpa-facilitate at nagpapatakbo sa buong Ohio River. At meron itong mixed natural gas and carbon-free hydrogen. Ito ay kinukompleto sa isang site ng aluminum cement dito sa Ohio River. The facility first will burn a fuel blend that includes 5% hydrogen in a General Electric CO or H-class gas turbine. Dito naman ay ito daw ang kauna-unahang facility na merong burn fuel na nagbe-blend daw ng may 5% hydrogen sa mismong General Electric gas nila or sa may gas turbine. The plant is intended to transition to 100% green hydrogen over the next decade by relying increasingly on renewable energy to power electrolysis machines that split water into its hydrogen and oxygen elements. Yung planta daw ay nag-i-intend ng transmission na hanggang 100% green hydrogen ang kaya niyang gawin over sa next decade pa daw. Ito ay nag-i-increase and nagre-renewable daw to sa energy ng power electrolysis machines na naghihiwalay sa papuntang hydrogen or oxygen elements. Siemens Energy. Construction begins on the world's largest green hydrogen plant, part of unique baseload solar project. Siemens Energy will operate the unique 170 million euros facility in a remote part of French Guiana, which will provide 10 megawatts of power during the day and 3 megawatts at night. Dito daw sa Siemens Energy, ang nag-ooperate daw ay unique na 170 million facility na euros para ma-provide ang 10 megawatts na power during the day and 3 megawatts at night. A unique baseload renewables project that combines the world's largest hydrogen power plant with a 16 megawatts machine for electrolysis of water and a 3 megawatts fuel cell, 55 megawatts of solar panels, and 20 megawatts to 38 megawatts per hour of batteries has begun construction in French Guiana. Dito natin makikita na unique base loaded daw na project itong pinakamalaking power plant sa French Guiana na nagsusupply ng 16 megawatts ang isang machine sa isang electrolysis of water lang. Then sa 3 megawatts naman sa fuel cell, 55 megawatts for solar panels. And ito'y nagkakaroon ng 20 megawatts to 38 megawatts per hour of batteries na nako-construct ng French Guiana.